solution. Solute plus solvent is equal to solution. One important point here is that how will we recognize whether it is solute or whether it is solvent? The first point to recognize how whether it is solute or solvent, uh, we will go through, or we will go by its amount. Generally, solute is a smaller in, or we can say lesser in amount, lesser in amount. And when we talk about solvent, it is greater in amount, greater or larger in amount. Like if you are going to make a solution, sugar plus water, this will be sugar solution. So from class 9th, you can see sugar is generally lesser in amount. That's why it is solute, and water is solvent because it is greater in amount. So it is solvent. This is the first method to recognize whether it is solute or solvent by uh, considering amount. Whichever is larger in amount will be solvent, and lesser in amount will be solute. But when there is another method to recognize whether it is solute or solvent, just go for physical state. You know that sugar is solid, water is liquid, but the physical state of sugar solution, can you tell me what is the physical state of sugar solution? Hamza, what is the physical state of sugar solution?
Sir, I don't understand.
You don't understand. So
I didn't study solutions before.
okay, no problem. Just think, okay, if you have some amount of sugar and you are going to put it in water, what will be the product? In
Sure,
this is
sir.
solid, this is solid, this is liquid. This is known as sugar solution. What? Just think about it.
It will
What
be
will be
aqueous.
it? It will be liquid. It will be liquid or not?
Yes.
If you have some salt and you are going to put this salt in water, it will give salt solution. And now the point is that this is solid, this is liquid, then salt solution is also liquid. Is that clear?
Yes, sir.
Now see, the second method to recognize whether which one is solute and which one is solvent, just go for physical state. Just I just told you that sugar solution has a physical state liquid, and then compare the physical state. This is liquid, this is liquid, and this is solid. The one which has same physical state as solution is the solvent. That means what does that mean? सॉल्यूशन का जो भी आपका फिजिकल स्टेट हो, इन दोनों में से जिससे भी मिले वो आपका सॉल्वेंट होगा और दूसरा वाला सॉल्यूट होगा. जैसे यहाँ पे आप देख सकते हैं सॉल्ट, वाटर, सॉल्ट सॉल्यूशन. सॉल्ट सॉल्यूशन का फिजिकल स्टेट क्या है? लिक्विड. यहाँ पे वाटर का फिजिकल स्टेट क्या है? लिक्विड. दैट मीन्स ये जो वाटर होगा यहाँ पे ये सॉल्वेंट होगा और ये जो होगा आपका सॉल्यूट होगा. So we have two methods to recognize whether it is solute and solvent. The first one is whichever is lesser in quantity, that is solute, and greater in quantity, that is solvent. And the second method, the physical state which has same as that of solution, it's solvent, and different the physical state with different physical state, that will be solute. Is that clear?
Yes, sir.
Okay, can I change the slide?
Yes.
Okay, so in our syllabus there is only binary solution. We have binary solution. Binary solution. What does that this binary solution means? Binary solution means a solution that contains only two components. A solution can contain more than two components. Like if you are going to mix, you can mix sugar, water, and salt. But in our syllabus, binary solution, I'm going to define it. The solution which contains, right, with more than two components is known as binary solution. Please write. And let me know if you are with this.
Okay, sir, done.
Very good. Now see, we are going to talk about concentration term. Concentration term. What is concentration term? Basically, how we are going to define solution that is called concentration term in terms of weight, in terms of volume, in terms of mass, or in terms of mole fraction, molarity, volume, number of moles per liter, number of moles of solute per liter, in terms of molality, normality. It's all concentration term. So I'm going to give you a list of concentration term, then we will discuss it one by one. Weight by weight percent, weight by volume percent, volume by volume percent, mole fraction, molarity, molality, normality, and then ppm, that means parts per million. Have you studied about it in class 11th? Done.
No, sir, wait.
Okay.
Sir, done.
Very good. Now we are going to discuss one by one. The first one is basically weight by weight percent. Let me ask you some question. Have you studied it in class 11th? Yes or no?
Sir, I don't know.
Okay. Weight by weight percent. Can you just see? Weight by weight percent. I am going to ask you. If it is asked or given in the question 5% weight by weight, what does this mean? So I'm going to explain it. This is numerator, which shows this is for basically solute, and in denominator, this is for solution. Since you can see weight, so it is basically 5 gram of solute present in 100 gram of solution. You can see whenever this type of words you have given, just write a full sentence about it. 5% weight by weight, that means 5 gram of solute present in 100 gram of solution. Now you already know that solute plus solvent is equal to what? Tell me. Solute plus solvent is equal to
Solid plus solvent is the solution.
solution. Now if I'm asking mass of solute plus mass of solvent, that will be equal to mass of
Mass of
solution or not?
solution.
Very good. So basically, if this is given, you can easily write the whole sentence, and by reading the sentence once carefully, you can find the mass of solution, because the mass of solute is given and the mass of solution is also given. So can't you find the
5
value
by
of mass
100.
of solvent?
5 by
Oh,
100.
5 by 100, 5 by 100 or 95.
Yes.
If this is moving to right side, it will be in negative. So the value is basically 95 gram. Yes or no?
Yes, sir.
So basically, whenever this type of uh, term is given, you can just write a whole sentence about it, and you can find the mass of, you can easily find the mass of solvent. Do you know how to calculate number of moles? Yes or no? Do you remember the formula of number of moles?
No, sir.
Okay, no problem. See, if 5% weight by weight is 5 gram of solute present in 100 gram of solution. If I'm giving you 10% weight by weight, can you expand this in the sentence in the same way?
Um, 10 by 100. 1 cut.
Not
1 by 10.
why 10 by 100. I'm telling you that if this was given, you can see 5% weight by weight, and I wrote a whole sentence about it.
Oh, okay, okay. Then it will be 10, 100 minus 10.
What do you want? 100 minus 10, what do you want to tell me? What
So
is 100 minus 10?
solve. You want me to solve 10% weight by weight for the.
No, no, no. I am telling you that 5% weight by weight, and for this I wrote a whole sentence.
Yes.
This. I want you to write a sentence about this in the same way that I wrote here.
Oh, okay. So it will be 10 gram of solute
Okay. Of,
present in
yes,
100 gram of solution.
present in 100 gram of solution. Very good.
Yes.
100 gram of
Solution
solution. So you can see with
90.
this with this a small quantity, this whole sentence you just make it. Okay. So 10 gram of solute and 100 gram of solution. So if I'm asking mass of solvent, that will be 100 minus 10, that will be 90 gram or not.
Yes.
This is very basic question, and generally it won't be asked in it won't be asked in examination. This weight by weight percent, weight by volume percent, and volume by volume percent will be the application in molarity, mole fraction, molality, and normality. Please just write it, and I will give you some question on this. But whenever this type is given, just write a whole sentence about it. Okay, with the sentence it will be more clear for you. Hmm. Let me know if you're done with this.
Okay, sir, done.
Okay. So I'm going to ask you again a question, and then I will give you a formula and then question again. If I'm going to write it like 7% weight by weight, what will you
It will be
tell me the sentence? This will
7
be like
gram
7 gram of solute
solute
present in
present in 100
100
gram of
since
solution.
yes, 100 gram of solution. So I'm going to write the formula. Weight by weight percent is equal to, be clear, weight or mass. In chemistry, weight or mass is same. Okay. So basically, weight of solute upon weight of solution into 100. This is the formula for weight by weight percent. Again, I'm going to give you a question. Please write it. 10 gram of A mixed with 100 gram of B. 10 gram of A mixed with 100 gram of B to make a solution. Calculate weight by weight percent. Please do calculate.
And weight of solute is 10 gram.
Done. Hamza done.
Um,
Hmm.
Sir, it will be weight of solute is 10 by 100 into 100, right?
No, not 100. Nora, are you there?
Yes.
Okay. You just joined it?
No, I joined 5 minutes ago.
Okay, I just saw it. Okay, Hamza, what is the formula for weight by weight percent? Weight by weight percent is equal to
Weight of
weight of
solute
solute
by
upon
solution
weight of
into 100.
solution into 100. Now you can see the one which is lesser in amount is solute, that is 10, and 10 gram of A is mixed with B, then a solution will make, right? Hamza,
Yes, sir.
then what is the mass of
110.
solution?
110.
110. into
into
100,
100,
and
0, 0,
if you are
correct.
going to solve it, it will be 9 point something percent. Okay, is it done, Nora? Up to which I had taught you, like Nora, am I audible?
Sir, could you please repeat what you just said?
Up to which topic we have studied in the we had studied in the last class, the first class basically.
Mole fraction.
Mole fraction. Okay, after 10 minutes it will be started. Then we will do some questions on mole fraction and we'll move to next topic, which is molarity. Hamza, are you done with this?
Yes, sir.
Okay, now see, second and basically first, second, and third terms are same. Second concentration term was weight by volume percent. If it is given that 10% weight by volume, what does this mean? I already told you that this is for solute, and in denominator this is for solution. Now see, since W is for weight, so we are taking W unit of weight, that is gram. So 10 gram of solute present in 100. This is for percent, that means 100, and you can see this is V for volume. So 100 ml of solution, 100 ml of solution, 10 gram of solute present in 100 ml of solution. In the same way, if we are going to write a sentence about 15% weight by volume, can you tell me a sentence about 15% weight by volume? Hamza or Nora?
15 gram of solute present in 100 ml of solution.
Very good. Present in 100 ml of solution. You can see this is for solute, and since it is W, that's why it is gram, and this is for solution, and percent is for 100, and that 100 ml or gram, that will be defined on this base, whether it is weight or whether it is volume. If it is W instead of volume, it will be used 100 gram, but 100 is the reference number. So in the same way, we can write a formula, weight by volume percent, that will be equal to weight of solute upon volume of solution into 100. Is that clear, Hamza?
Yes, sir.
Please write it. And in the same way, we can write about volume by volume percent. You can see if it is given that 7% volume by volume. I already told you that this is for solute and this is for solution. Now see, this is 7% volume by volume. 7. Since it is volume, we will use ml. 7 ml of solute present in 100 ml of solution. Please write it. Then I will give a formula for volume by volume percent, and then we will move to next topic. This is very easy. There will be very rare question directly on weight by weight percent, weight by volume percent, or volume by volume percent. But it will be used in making tough questions of molarity, normality, and molality. Done. Hamza, are you done with this?
Yes, sir.
Okay. Now see, if you are going to take a for volume by volume percent, it will be volume of solute upon volume of solution into 100. This is the formula for volume by volume percent. Please write it and let me know if you are done with this. We will start mole fraction. Here represented by chi. Done, Hamza. Are you done with this? Hamza, you are not audible. Nora, are you done with this?
Yes, sir.
Okay. Now see how we are going to define mole fraction and okay. Okay, Hamza. Fix your mic. Mole fraction. I'm taking an example with a container in which A and B is present. A has a number of moles Na, B has a number of moles Nb. Now see, mole fraction of A. If we are going to calculate mole fraction of A, that will be denoted by chi A, and it will have a formula that is number of moles of A upon total number of moles in the container. So you can see only two components are present. So it will be number of moles of A plus number of moles of B. In the same way, if you are going to calculate mole fraction of B, this is basically chi B, and it has a formula number of moles of B upon total number of moles of container. And you can see since container has two component, then it will be number of moles of A plus number of moles of B. So basically this is formula for calculating mole fraction and mole fraction. And you should know that how to calculate number of moles. Number of moles is equal to, we have three formula for number of moles, that is given mass upon molar mass. This is the first formula. Second formula is basically given number of particle upon Avogadro number. The third number of formula for the mole fraction is given volume upon molar volume. You should know that molar volume is 22.4 liter, or in some books it is given that 22.7 liter. This Na, you already know that Na is Avogadro number, and it is a value 6.023 into 10 raised to the power 23. And this is molar mass. You also know that how to calculate molar mass. Can you calculate molar mass? So there will be a container or a solution in which you need to calculate the mole fraction of the required component. So you should know the formula, and you should know the formula of how to calculate number of moles. Is that clear, Hamza?
Yes, sir.
Please write it and let me know if you are done with this. Then I will give you a very simple question. Then we will move to the next. If you are done with this, let me know, please. Hmm. Nora, are you done with this?
Yes, sir.
Hamza, Hamza, please speak up. Are you done with this?
Yes, sir.
Okay, I'm going to give you a question. It's a very easy question. 5 gram of NaOH mixed in 90 gram of H2O. Calculate mole fraction of NaOH and water. If you are unable to solve it, please ask me. And if you are able to apply the formula and solve it, that's very good. Please do it. Done. Nora, any answer? 8 बजे तक क्लास है, उसके बाद ही आऊँगा। हाँ हाँ ठीक, आऊँगा तो कॉल करता हूँ। Are you done with this, Nora? Nora, am I audible to you? Please speak up. It's Hamza, please speak up. Okay, I'm going to explain it. 5 gram of NaOH mixed in 90 gram of H2O. That means in the container, NaOH plus water is present. Now you can see we need to calculate according to the question mole fraction of NaOH. That I can also write chi NaOH, that means mole fraction of NaOH is equal to number of moles of NaOH upon total moles. That means number of moles of NaOH plus number of moles of H2O. Now you can see number of moles of NaOH. That is not given directly, but it is given like 5 gram of NaOH. But we can easily calculate number of moles of NaOH if mass is given, that is 5 gram. What is the molar mass of NaOH? Please speak up. What is the mass of molar mass of NaOH?
40.
40. So it will be 40, and you can see it is 1 by 8 mole. Again, number of moles of H2O, given mass is 90 gram. So 90 gram. And what is the molar mass of H2O? That is 18. So it will be 5 moles. Now you can see, put the value of number of moles of NaOH, that is 1 by 8 upon 1 by 8 plus 5. And again 1 by 8. And if you are going to take LCM, it will be 8 plus 1. 1 8 so it will be 40. And again you can solve it 1 by 8. 8 by this is 41. So the mole fraction of NaOH will be 1 by 41. And again the mole fraction of H2O, that will have a formula, number of moles of H2O upon number of total moles. That means number of moles of H2O and number of moles of NaOH. And it will be 5 upon 5 plus 1 by 8. Again 5 upon, you can see if you are going to take the LCM, if you are going to take the LCM, it will be 8, and it will be 40 plus 1. Now you can see 5 upon 41 upon 8. This 8 will be in numerator, and it will be 40 upon 41. So this is the mole fraction of H2O, that is 40 by 41. And this is the mole fraction of, this will be the mole fraction of NaOH, that is 1 by 41. Is that clear, everyone? Both of you. Please speak.
Sir, your
Yes, sir.
voice is breaking.
I'm telling you that, is that clear, or you need?
Yes, sir, it's clear.
Okay. Can we move to the next part? Can I change the slide, or are you writing? Nora, can I change the slide?
Yes, sir.
Okay. Hamza, I'm changing the slide. No, I'm going to give you another question. 23 gram of NaOH in 54 gram of H2O. Calculate mole fraction of NaOH and H2. Please do it. Please let me know if you are done with this or you need to ask anything. Done, everyone? Not are you done with this?
Yes, sir.
What is your answer?
23 by 143 of sodium hydroxide and 120 by 23 of H2O.
Wait a minute. What is the mole fraction of NaOH? 23 by
143.
and what is the mole fraction of H2O?
120 by 23.
I think it's wrong. Just see. This is given. This is given. Maybe it's calculation mistake. Just see. Mole fraction of NaOH will have a formula. Hamza, please interact with me. Otherwise, you will be left behind with all this misconception. Okay. Mole fraction of NaOH will be equal to number of moles of NaOH upon number of moles of NaOH plus number of moles of H2O. But most importantly, number of moles is not given directly, but its mass is given. Oh, maybe you are correct. Basically, I should give here C2H5OH so that it will be cancelled, but I have given something else. No problem. Number of moles of NaOH, that is given mass upon molar mass. Given mass is 23 and molar mass is 40. Okay. And number of moles of H2O, you can see 54 by 18, that is 3 moles, right? Nora? Nora, is this
Yes.
clear? Wait a minute. I should check again your answer. That will be equal to, okay. And again, no, this is wrong. So, okay. See, a number of moles of NaOH that has a value 23 by 40, and again 23 by 40 plus number of moles of H2O 3, and number of moles of H2O, mole fraction of H2O, number of moles of H2O, it will have a formula, again number of moles of H2O plus number of moles of NaOH. Again, what is the number of moles of H2O? H2O has a number of moles 3 upon 3 plus 23 by 40. Again, yeah, can you calculate it, Nora? Nora, can you calculate it? You can see this is 23 by 40, and again we are going to take LCM. It will be 40, and again 23 plus 120. So if you are going to solve it again, it will be 23 by 40, and upon this will be 143 upon 40, and again it will be 23 by 40 into 40 by 143. That's great. Your first answer is 23 by 143. That's great. This is your first answer, which is very correct. That is mole fraction of NaOH. Let me check the another one. That means this part. So if you are going to calculate it, 3 upon, if you are going to take LCM, it will be 40, and again it will be 120 plus 23, and again it will be 3 upon 143 upon 40. This 40 will goes up here, and it will be 120 upon 143. This was your wrong answer. Nora, are you getting my point?
Yes, sir.
You made a slightly mistake. This shouldn't be 23. You can see after taking LCM, and this will be 120 plus 23, it will be 143, and this 40 will go into numerator and multiplied by 3, so it will be 120 by 143. Hamza, are you getting anything, or it's all bouncing?
No, sir, I understand.
Okay. Let me know if you're done with this. Hamza, can I change the slide?
Yes, sir.
Okay. I'm going to give you a very easy question. I already told you that this weight by weight percent, weight by volume percent, and volume by volume percent, it will be used in mole fraction, molarity, and normality. If I'm going to give you 10% weight by weight NaOH in aqueous solution, calculate mole fraction of NaOH. You should know that whenever we talk about mole fraction, that means more than one component will be there, or you can see if there is solution, that means more than one component is there. Another important point is that NaOH in aqueous solution. Can you read this sentence and tell me what is the solvent? What is the name of the solvent? NaOH in aqueous solution. What does this means? NaOH is present in which solvent? Hamza, Nora. See, I want to tell you that this aqueous solution, that means it is present in water. Can you do it?
Moles of solute by
What you just said, Hamza? Nora, can you do it?
Yes, sir, I'm trying.
Okay, Hamza, are you trying or I should explain for you?
Sir, please explain.
Okay, just see Hamza, what is asked. What we need to calculate is mole fraction of NaOH. And mole fraction of NaOH has a formula, number of moles of NaOH upon total moles of NaOH. Total moles. Total moles, that means NaOH is present as well as aqueous solution, that means H2O is also present, right?
Yes.
Now see, what is given? Given is that 10% weight by weight. 10% weight by weight NaOH. NaOH is solute, you can see. So if you are going to write a whole sentence about it, this will be 10 gram of NaOH, that means solute. 10 gram of solute, that means NaOH, present in 100 gram of solution. Can I write this? Interact with me, Hamza. Now you can see NaOH has a mass 10 gram and solution has a mass solution. Since it is aqueous solution, that means water H2O is solvent. H2O is solvent. So mass of solvent, that means H2O, will be equal to 90 gram or not? Hamza,
Yes, sir.
mass of water is 90 gram. Now you can
Yes.
see 10 gram of H2O is given. Mass of H2O solvent is 90 gram. You already calculated it. So now number of moles of NaOH we need to calculate. Number of moles of NaOH given mass, that is 10 gram, and molar mass of NaOH 40. So it will be 1 by 4 moles. Again, number of moles of H2O, that is given mass 90 gram and molar mass of H2O 18. So it will be 5 moles. Now I am going to put the value and calculate it. Mole fraction of NaOH is equal to number of moles of NaOH, that is 1 by 4 upon 1 by 4 plus 5. Again, if you are going to calculate it, take LCM 4, 1 plus 20. 1 4 ja 4, 4 5 ja 20. This will be equal to 1 by 4, 4 by 21. And it will be cancelled. So the mole fraction of NaOH is equal to 1 by 21. In the same way, if it will be asked like, what is the mole fraction of H2O? You can calculate it. Number of moles of H2O upon number of moles of H2O plus number of moles of NaOH. Number of moles of H2O is 5 upon 5 plus 1 by 4. So you can calculate it here. Take LCM 4. It will be 20 plus 1. It will be equal to 5 upon 21 upon 4. It will go in numerator. So it will be 20 upon 20. So here is how you can calculate. It is easily. It's very easy to calculate the mole fraction. Please let me know if you are done with this. Are you done with this?
Yes, sir.
Very good. Hamza, are you done with this?
Yes, sir.
Now see, I'm going to give you another question. Then we will move to the next topic, which is molarity. C2H5OH, chemical name is ethanol alcohol. Please do this last question. Take your time and do it correctly, accurately. Nora, are you done?
I'm doing, sir.
Okay. Hamza, are you solving it or you need an explanation?
Sir, I solved it.
Okay.
Done, sir.
What's your answer? Your answer, Nora. Mole fraction of C2H5OH
23/59.
and mole fraction of H2O. Mole fraction of H2O, Nora. Are you solving it or?
Uh, 36/59.
36 by 59. That's good answer. Hamza, just see, mole fraction of C2H5OH, that will be equal to number of moles of C2H5OH upon number of moles of C2H5OH plus number of moles of H2. Number of moles, I'm going to find it here. Number of moles of C2H5OH, that will be equal to given mass upon molar mass. Molar mass of C2H5OH 46, right, Nora? So it will be half mole. Again, number of moles of water, that is 54 divided by molar mass 18. It will be 3 moles. So I'm just going to put the value here and you can easily calculate it. Number of moles of this will be 1/2 upon 1/2 plus 3. So it will be mole fraction of C2H5OH. That will be equal to half upon taking LCM 2. So it will be 1 plus and 2 3 is 6. So it will be 1 by 2 upon 7 by 2. It will be 1 by 2 into 2 by 7. The answer is 1 by 7 basically. Nora, how
Yes,
many
sir. I
number?
did wrong.
Okay, just see. Number of moles of H2O, mole fraction of H2O, it will be number of moles of H2O, that is 3 upon 3 plus 1 by 2. Now you can see 3 upon, if you are going to take LCM, it will be 2 and 2 3 is 6 plus 1. And now you can see 3 by 7 by 2. And this 2 will be going to multiply into the numerator and 6 by 7 it is. So this is the correct answer. Hamza, are you there? Please correct it, Nora. Then we will move to the molarity part.
Done, sir.
Hamza, are you there? Now see, we are going to take the next concentration term, that is molarity. Molarity is denoted by capital M. First, I'm going to define it. Basically, what it is number of moles of solute present in volume present in, wait a minute, number of moles of solute per unit volume of solution per unit volume of solution in liters. So basically, if you are going to arrange this whole sentence into uh, a mathematical equation, it will be molarity equals to number of moles of solute upon volume of solution in liters. Number of moles of solute upon volume of solution in liter. And what is the unit? You can see in numerator it is moles and volume of solution in liters. So the unit is moles per liter, or we generally use capital M. If there is 2 moles per liter, that means we can also write 2m. So basically this is the formula for molarity, which is very easy. Now we will learn how to apply the formula if the sentence will be different. Hamza, are you there? Now are you done?
Yes, sir.
Okay. I'm going to give you a question. Please answer me. It will be very easy. 23 gram of C2H5OH present in 250 centimeter cube of solution that is volume. Calculate molarity. The first question, which is very easy, it is based on the formula, and you need to know the conversion, which is very important. Then Nora, see, I'm going to explain it. What we need to calculate, see, 23 gram NaOH is given, 23 gram of, sorry, C2H5OH. You can also see volume is basically 250 centimeter cube, which you can easily calculate it into, or convert it into liter divided by 1000. So it will be basically 0.25 liter. Now see, molarity as a formula, number of moles of solute upon volume of solution in liter. But here number of moles is not directly given, it is given mass. So it will be applied given mass upon molar mass upon volume of solution, which means 25 upon 100. I can write 25 upon 100. Now we can easily calculate it, 23 by 46 into 100 upon 25. Again, you can easily see 23 to the 46, 25 4 the 100, and 2 to the 4. So the answer is 2 moles per liter, or 2 m. Just check it out, Nora. Hamza, are you there?
Yes, sir.
So do you have any doubt in this?
No, sir.
Okay.
Done, sir.
Then now see, I'm going to give you a very easy question, but this is basically the application of weight by weight percent. So I'm going to give you 10% weight by volume NaOH. Calculate molarity. Calculate molarity. What I taught you is very important. I told you that whenever this type of term is given, please write a whole sentence and then see what is given and what it is asked. Calculate molarity. Write the formula of molarity, write the whole sentence, and just check it out what is given and what you need to calculate. Can you do this, or I should explain? Nora, are you done with this?
Yes, sir. Is it 2.5 m?
Okay, I will check it out. Just see, I'm going to explain it. 10% weight by volume, that means 10 gram of solute or 10 gram of NaOH present in present in 100 ml solution. Present in 100 ml solution, right? Now you can see molarity is asked, number of moles of solute upon volume of solution in liter. What is the solute? You can see this is the solute. And what is the volume? This is the volume that is given. Now just apply the formula, number of moles, given mass, that is, or upon molar mass, upon volume of solution, that is 100 ml, but we need to calculate it into liter. So we need to divide it by 1000. Now 10 by 40 into 1000 by 100. Again, 20 will be cancelled by 20, 10 will be cancelled by 10. So it will be 10 by 4. 2 to the 4, 2 5 the 10. Yes, very good, Nora. This is the answer, 2.4 mole per liter. Okay, Hamza,
Yes, sir.
please write it.
I am writing, sir.
Very good. Done, Nora. So see you in the next class with a new topic of molarity. There are three types of molarity or three kinds of question you can say. Molarity on dilution, molarity of mixture, molarity of ions. So most probably in the next class, we will complete molarity, molality, and ppm. Or if there will be time, we will also complete normality. After this concentration term, we will go for Henry's law and then Rawls law, the main chapter from class 12th. Is that clear, Nora and Hamza?
Yes, sir.
Okay, see you in the next class. Thank you for today.